Green.
Tranquility Base here. The Eagle has landed. Rocket Tranquility, we copy you on the ground.
New possibilities are opening up for scientific cooperation between countries.
1-0. Liftoff. Americans return to space as Discovery clears the tower.
Discovery, go and throttle up.
Discovery, roger. Go for deploy.
Everybody in the shuttle program, the crew must go for launch.
Roger. Nice to be in orbit.
We have followed in their footsteps to get us where we are today.
Hey, from NASA's Kennedy Space Center, Florida, welcome everyone to today's traditional pre-launch news conference. It's good to be able to say that. Following today's launch readiness review, ahead of NASA, Boeing, and United Launch Alliance's Orbital Flight Test 2 mission to the International Space Station. This will be the second uncrewed flight of a Starliner atop an Atlas V from Space Launch Complex 41 over on the Cape Canaveral Space Force Station. And this one is going, obviously, to the International Space Station. Here to provide details of today's review and readiness to proceed toward launch are a distinguished panel. Let me introduce them, and then I'll turn it over to them. Steve Stitch, manager of NASA Commercial Crew Program here at Kennedy Space Center. Joel Montalbano, the manager of the National Space Station Program based at the Johnson Space Center in Houston. Jennifer Buckley, also from Houston. She's the NASA ISS Deputy Chief Scientist. John Vollmer joins us. He's the Vice President and Program Manager for Boeing's Commercial Crew Program. Also joining us, Gary Wentz, Vice President, Government and Commercial Programs for United Launch Alliance. And also, Will Ulrich, Launch Weather Officer, U.S. Space Force 45th Weather Squadron. Again, we'll hear from each participant here, and then we'll throw it out for questions. And with that, I'll turn it over to Steve.
Thanks, Kyle. It is great to be here today following the launch readiness review this morning. When we look back to last week, we had our agency flight readiness review on Thursday. We've closed out all of the open work from that review. We had a good, thorough launch readiness review this morning, and we're in good shape to move forward and to roll the spacecraft out and also the launch vehicle. It was great to be up at Launch Complex 41 this morning. We got to walk down the launch vehicle and Starliner and see the Atlas, the Centaur, and also the Boeing Starliner spacecraft, and it looks beautiful. Really a testament to all the teams that have worked so hard from Boeing, NASA, and ULA over all these 18 months to get ready for the flight. Gary and John will talk a little bit more about processing the hardware, but we're on track for the launch on this Friday, which is launch time of 2:53 p.m. Eastern. We do have multiple backup dates. Right now, the range would not be available on the 31st, but we would go likely to Tuesday, August the 3rd, with a backup launch time of 1:20 p.m. on August the 3rd. We talk a lot about the launch and getting ready for launch, but it's a very important flight for the Commercial Crew Program, having our second space transportation system available to carry crew to space. This flight will test many of the important systems on the vehicle in preparation for crew, such as the rendezvous sensor package to dock with the International Space Station, the NASA docking system. It'll be the first test of that system on the vehicle. And then when we get docked, there's a lot of activities we're going to do. We'll do some audio tests with the crew to test the comm system with the crew from space using the space station assets. We'll see how the vehicle performs on orbit in terms of the thermal performance, and also while docked, the atmosphere exchange. And we'll do some tests also with the crew tablets and syncing those and taking data off of Starliner through the space station and then updating the tablet. So it's an important test flight for us. Right now, the plan would be to undock as early as Monday, August the 5th, and land that same day. And we would look forward to that as well. We'll stay up as long as we need to relative to weather. The ISS has plenty of consumables. But we're excited about the flight and looking forward to a great mission. And now I'll turn it over to Joel Montalbano.
Well, thank you, Steve. You know, again, welcome to today's press brief. This week has been very busy on board ISS as we prepare for the MLM docking this week and then the OFT-2 launch and docking. We have been keeping the crew up to speed on all the operations that have been happening here on OFT-2 preparation, and they're excited as we are. With 7 people on board, we have an opportunity to maximize the use of the International Space Station, maximize the use for research and utilization, the technology development that we'll use to go back to the moon, and for low Earth orbit commercialization. So it's really been nice to having all 7 crew members. So with 3 NASA crew members, a European crew member, a Japanese crew member, and 2 cosmonauts, it's really been a pleasure to have this crew on board. As you heard, we had our launch readiness review today with the Boeing team, the ULA team, and the commercial crew program. And the ISS program is not working any non-standard open work. So we're ready to go for launch, and we're excited to have that. Steve talked about the launch time at 2:53 p.m. Eastern Time. We're carrying about 475 pounds of NASA cargo up and approximately returning 575 pounds of NASA cargo. And so we're excited to have another vehicle capability. Once this vehicle is docked, this will be the first time we'll have 2 U.S. crew-provided vehicles on board the International Space Station. So while we've had 2 crewed vehicles before, they were both Dragons. So this will be the first time we're having another provider on board. And that adds to the robustness of the space station program. And that helps us, not only the NASA agency, but it helps the partnership across the globe and allows us to bring people to and from the International Space Station and have redundancy in that process. And again, maximizing our use of the great space. You know, I tell people all the time we have awesome jobs, and in fact, I tell people we have the coolest jobs in the world to work in the space program and work with people across the globe and to make things happen. It's been a pleasure working with the Boeing team, the ULA team, the commercial crew program, and obviously our international partners and everyone involved in making this mission a success. So we're excited. We're looking forward to do that. And with that, I'll pass it over to Jennifer. Thank you.
Thank you, Joel. I'd like to talk for a few moments about the research we're doing on ISS, as well as some of the experiment hardware we're going to be bringing back on this flight. To date, we've done over 3,000 experiments on the International Space Station. Those come from over 100 countries and have resulted in over 2,000 publications, and we've served over 4,000 scientists and researchers. On this particular flight, we're going to be bringing back hardware that has been used on board to support some of those experiments. 2 of those experiments are in the field of tissue engineering. So we'll be returning hardware from the magnetic 3D cell culture experiment. That is from a company called In3D Biosciences. They developed and commercialized a cell levitation technology using magnets. And what this does is it supports the cell's binding to magnetic nanoparticles, which then can be magnetized into 3D aggregates. This is really important research that we've been doing in microgravity. We know that cells more readily form 3D structures and spheroids in microgravity, and so this was one of our early research and development as well as tech demos for bioprinting. We're also going to be bringing back hardware from antibody drug conjugates, or ADCs, in microgravity. This is in the field of cancer biology. This experiment tests antibody and drug conjugates using cancer therapeutics attached to antibodies. So what this does is it allows you to target specific proteins on the cells, on the outside of tumor cells. This not only can create more effective therapies, but also can reduce side effects since the drug delivery is very specific. We just talked about how the cells more readily form 3D structures. It is also believed that potentially doing this type of research in microgravity could approximate the 3D structures of tumors more in the human body than what you would get from trying to grow these in 1G. We're also going to be bringing back experiment hardware in the field of complex fluids. That is PACE, our preliminary advanced colloids experiment. This was an initial experiment used to calibrate our light microscope on board and enable an entire suite of advanced colloids experiments that continue today. And now I'd like to hand over to John.
Thank you, Jennifer. Well, it's a pleasure to be here today. I would like to show a slide from this morning. Steve mentioned that we walked down the Launch Complex 41 with the vehicle. You can see the Starliner there atop the Atlas V vehicle. In the background, you can see the Launch Complex itself, and so we are looking forward to getting there. So we made it one of our objectives for this mission was to be full kit. We wanted to avoid any traveled work, and so I'm very proud of the Boeing team, all of our supplier partners with ULA, Aerojet Rocketdyne, Collins, ILC, and many others. But they, along with us working side by side with NASA, have, through this entire journey, we made it through FTRR, the FRR, and then this morning, the flight readiness review with very, very few actions. And so we're very pleased to have been able to accomplish that with a very clean vehicle. And that was one of our objectives. We tried to make the Starliner for this trip, this mission, as close to a crewed vehicle as we could. And so we will be obviously working all the objectives and the flight demonstrations to prove that out. We will do everything we can except for the man in the loop, and even in those cases, we've enabled the abort. So that will be enabled for this flight so that we can check that system out. So another one of our objectives, we have our ops teams in both Houston with mission operations. We have our ULA team here at KSC, and we also have our Boeing Mission Control Center here at KSC. All the operators have been certified and trained, and they are ready to go for this flight. So we are very excited to have the opportunity to complete this test flight and have it be a leader for our path for the crewed flight to get us to ISS in the future. And with that, I'll turn it over to you, Gary.
Thanks, John. ULA is excited to be here to launch the second orbital flight test in partnership with NASA and the Boeing company. This will put us one step closer to flying astronauts to the International Space Station from U.S. soil. We're especially honored to partner with Boeing and NASA and really appreciate the trust and confidence that they've put in our team and the Atlas V to launch the Starliner to space. This second flight gives us an opportunity to further analyze the mission-unique technologies that were developed specifically for use on the Atlas V and the Starliner configuration. These include a dual-engine Centaur like we launched on OFT-1. That has history back into Atlas II and Atlas III, and we plan to use that on future Vulcan Centaur flights as well. This Centaur uses an Aerojet Rocketdyne RL-10 engine that was specifically designed by NASA back in the 1950s and 60s. And for this mission, we actually fly two of the RL-10 4A2s on the Centaur upper stage. The second technology specifically for this configuration involves the aeroskirt that was designed and put in place to improve the aerodynamic surface and to protect the Centaur upper stage from the loads, the aerodynamic loads that impinge on the vehicle during flight. It's a metallic orthogrid structure that you'll see when we roll out to the pad. You'll be able to see that structure extending down below the capsule over the upper stage. Unlike the orbital flight test, a couple things have been mentioned about the aborts. We flew the orbital flight test in a passive mode, doing data collection on all the telemetry and vehicle parameters. On this flight, we actually are activating that system, and so in the case of any off-nominal data that we get from the vehicle, we can actually command an abort to the Starliner. I think we have a photo that I can share of the vehicle. It's actually in the VIF, and we're on track from a health and status perspective. We walked down the vehicle today. There are no issues. They're doing some final closeouts. We're not working any issues, and all the planned work is nominal going forward with a scheduled roll to the pad tomorrow morning. we completed the LRR and look forward to a launch on Friday. And with that, I'll pass it off to Will Ulrich for the weather.
Thanks, Gary. Kind of feels like all eyes are on weather at this point. So anytime me and my colleagues see a launch being put on the schedule or on the calendar during the summer months from Kennedy Space Center or Cape Canaveral Space Force Station, we always have to be prepared for a challenge. And this particular launch is no different, especially given the time of the instantaneous launch window just before 3 p.m. You know, this time of year, anyone who's familiar with East Central Florida weather knows that each afternoon we typically see showers and thunderstorms over the area. But it really is dependent upon the placement of the Bermuda High out over the Atlantic waters as to whether the west coast of Florida or the east coast of Florida is favored for shower and thunderstorm activity each afternoon. Well, this week, the Bermuda High is to our south, which leads to offshore flow or west to east winds. What that means for you and I is it typically favors showers and thunderstorms on our side of the coast, which is obviously not good news when you're attempting to launch at 3 o'clock in the afternoon. So that's part of the reason why, if you've seen our forecast from the 45th Weather Squadron, we're a little bit pessimistic going into week's end, but we do have to be realistic with that. So if we take a look at the forecast, you'll see our probability of violation at this time is 60%. That's a 40% go, with 3 primary concerns. At the 45th Weather Squadron, we evaluate 9 separate lightning launch commit criteria. I highlighted 3 on the slide here, including the surface electric fields rule, the cumulus cloud rule, and the lightning rule, all rules that are designed to protect from both natural and rocket-triggered lightning. In addition, we'll be monitoring winds and other user constraints, but overall, outside of any thunderstorms, we are expecting favorable winds and temperatures in the middle 80s, not atypical for this time of year, and southerly winds up to about 15 miles per hour. So with that said, we have to be realistic going into late week, and we can hope that we'll find a gap in the shower and thunderstorm activity that we're anticipating. But regardless, the 45th Weather Squadron is ready to support regardless of what Mother Nature throws at us. Thanks.
Okay, thanks, Will. Thanks, everybody else. And we're ready to take questions here in the room, which, by the way, it's good to be able to say that again. And on the phone, we have some folks on the phone lines as well, so we'll bounce back and forth. And let's start first with Irene right here in the middle. And if you would, Irene, give your name and affiliation for everybody listening, and if you have a person up here to direct it to, do that also. Thanks.
Thanks, Kyle. Irene Klotz with Aviation Week. Either for Gary, probably for Gary, does the fact that you have a fully armed launch abort system affect the weather launch criteria at all? Are you looking at abort zones like you would if there was a crew on board, and would that impact your ability to launch on Friday?
So from a United Launch Alliance perspective, we're looking at all of that. It doesn't, we don't differentiate whether or not it's active or inactive. We have set launch constraints, and we'll adhere to those regardless of whether or not the abort system is activated or not. From a mission operations perspective, I think Steve's probably better.
I'll add a little bit to that. So we'll have the abort system active. So if anything were to happen, it would separate Starliner and land the vehicle. We are going to practice the abort weather for this flight, but we won't make those mandatory constraints. In other words, we'll just use the launch weather for this flight as the primary weather criteria, and we won't, we wouldn't hold the launch for abort criteria, but we are going to look at them and go through it just like if our crew were on board when those launch abort criteria would be in place, and we would follow those for the flight.
Okay, let's head to the phone line. Bill Harwood, CBS News.
Hey guys. A quick question for maybe it's Gary or maybe it's Mr. Vollmer. Can you give us a little bit more detail on the EDS system, the emergency, the fault detection system you've got for this flight that'll be live? I'm not clear on how that ties into the Atlas's, the self-destruct system that's always been in place on Atlas. How does that work? So if it triggers an abort, the capsule gets away, right? But what happens to the rocket and all of that? If you could just provide some background, I'd appreciate it. Thanks.
Thanks, Bill. I'll take a first cut at that. Okay. The quick answer is it's measuring, it's got 25 different measurements. It's looking at tank pressures, it's looking at our avionics, our flight control and attitude, and the propulsion systems, and it's verifying that they're performing nominally. And then if it's starting to see a trend where there's starting to get some issues with the vehicle, it'll actually initiate a command to the Starliner for an intent to an abort. So it's up front of the FTS, and if it's rapidly occurring, then it would kick it off sooner. Otherwise, it would just inform Starliner of what was going on the vehicle.
Right. From a Starliner standpoint, we actually have multiple abort modes depending on which phase of flight we're in. So fortunately, on the OFT-1 flight, we were able to evaluate the abort system on the ULA Atlas V. So with that data, we are very confident in activating that system and getting that prepared for our CFT flight. Once again, trying to make this vehicle as close to the CFT vehicle as we can. It allows us to go through and also demonstrate and validate that system. So,
Ken?
Hi, Ken Kramer, Space Up Close. For John Vollmer, I have a question. You mentioned this Starliner is as close as you could make it to launching humans. I'm wondering if you could actually launch humans on this flight, and if not, what would you have had to add? And if you could just tell us a little status of the other two Starliners. Thanks.
Okay, so we probably could have launched crew on this flight. We did not load some of the oxygen on this flight on purpose. We loaded nitrox instead of oxygen, so that would be one change we would have to do. But we have the full complement of hardware. The suit fan is in there for the suits to connect to. We're going to have a simulated suit connected so that we can validate that system. What was the second part of your question?
The other Starliners.
Oh, the other Starliner. So this is actually the Starliner that went through our environmental qualification testing, and then it's been refurbished for this mission. The OFT-1 Starliner vehicle is being refurbished for the CFT mission. Those are the two primary vehicles. Our third vehicle was our test vehicle, and that remains, it will not fly again. It remains a test vehicle, and we use it for human factors analysis. We use it for fit checks for equipment and things like that. But those are our two primary vehicles that we will continue to turn around. They're certified for 10 flights each.
Okay, back to the phones. Gina Sanseri, ABC News. Okay, let's take another one in the room right here.
Hi, Rachel Nail with Florida Today. For Steve, I'm curious, whatever happened with the Boeing organizational safety assessment? When was that finished, and what were the results?
Yeah, we did complete an organizational safety assessment over the summer months in the June timeframe at the Kennedy site here and also in Houston, and I think we've got some good information to go look at and go to utilize for to go and improve things. And so I really can't share too much data. It really goes to Mr. Vollmer and the team as well to take that data. But we didn't really see anything in the survey that was surprising, I would say. Boeing has an excellent safety culture that we've seen. We knew that before we did this OSA in working side by side with Boeing. But we'll take some feedback from employees, and then we'll take that and make the program better, both on the NASA side and also on the Boeing side.
Yeah,
okay, right.
And I'll add to that we were very pleased to work with NASA. We worked cooperatively on the organizational safety assessment. We assessed both our workforce in Houston as well as the workforce here at Kennedy Space Center. The results we just outbriefed just recently, and so we are ruminating over those, and we'll assess what the opportunities are that come out of that. We were Pleased with how the review went, particularly the professionalism that NASA showed and how they conducted the review, our allowance to be involved in how that review was conducted. And there's always room for improvement. So we're going to be looking for where are those areas where we can make improvement.
So will it be released or no, it won't be released?
The plan would not be to release the data. Again, when we do these, you know, you really want employees to feel free to speak exactly the way they feel, right? And so for them to provide that data in a very forthright manner, you have to protect that data. And so we won't really release the details of what came out of that organizational safety survey. We've done a number of these at NASA across many different providers and also within NASA as well. And the process really is to let people say what they think. And so if you release that data, you don't really get true data from the employees. And so, you know, John and I did get an outbrief. I can say, you know, just a core value of Boeing and a core value of NASA is safety, and that comes out very clear in the survey that safety is the #1 priority. And then the team also, you know, we do see that the team is dedicated to the mission and dedicated to this OFT test flight and dedicated to flying crew safely as well. So that's probably about all I could comment on.
I'm Amy with Space.com, and my question is for Mr. Vollmer. I wanted to talk about Rosie, the dummy that's on board. I know that you said this launch you probably could have put crew on board. So is there anything new with Rosie as far as sensor-wise or different things like that with this flight?
You know, we took a little bit different approach with Rosie this time. Last flight, she was fully censored, and we used those sensors, and they were very valuable data that we got back. This flight, Rosie's there, but she is essentially ballast. And we are taking measurements. We've put censored in the seats and other locations in the vehicle as we found that we thought that would be more valuable since we'd gotten the data from Rosie on the first flight. So a little bit different approach, but she's still there.
Okay, let's try the phone line. Do we have Gina back from ABC News?
Yes. How many full mission simulations did you run in prep for this?
I'll take that one. I don't know the exact number of total mission simulations that we ran, but I can tell you it was in the hundreds and hundreds of mission simulations. We ran mission simulations as we went through the development process. We ran mission simulations as we went through the test process. And then when we were completed with all the tests, we ran an end-to-end simulation, including all of the operations centers at KSC and Houston. And we even involved the crew in some of that so that they actually sat on a simulated flight deck. So I don't know the exact numbers, but I can assure you it was in the hundreds and hundreds of simulations that we ran and literally thousands of hours.
Okay, let's take one more from the phone. Jeff Faust with Space News.
Hi, Jeff Faust, Space News. A quick question on schedules. If you aren't able to launch on Friday and aren't able to launch on August 3rd, when is the next available launch opportunity? And what is the range issue that appears to prevent a launch opportunity on Saturday? Thanks.
So our next launch opportunity, if we don't go on the backup day of the 3rd, is the 4th of August, and it moves back on the order of 20 minutes in the launch time. And the operation on the range is a classified operation that they're conducting. And so we're continuing to be ready in case that operation doesn't go through, and we could launch earlier, but unless it moves, we'll just stick with the launch on Friday and follow up on the 3rd and 4th as backup days.
Can take another question in the room. Anyone else? Irene, go ahead.
Always have more questions. For Joel, following up from the post-FRR press conference on the opportunity to fly cosmonauts on the commercial crew vehicles and vice versa. Kathy previously had said that was going to be targeted between Crew 2 and 3. It sounds like it might be later now. Do you have another estimate of when that might be?
Yeah, it will not be on Crew 3. We're looking at try and get everything ready to go for the Crew 4 mission is our goal. But again, we'll have to continue work with our State Department, the Russian Ministry of Foreign Affairs, obviously NASA and Roscosmos, and then go through the standard process. We have you probably are very familiar with the multilateral crew operations panel process that we have, and we'll have to work through that. But it will not be Crew 3, Crew 4 at the earliest.
Okay, hang on. We'll go to the phone and then back here, Ken. Let's see. Eric Berger, Ars Technica.
Hi, thanks for doing this, and best of luck with the mission and launch this weekend. First question is for Steve or Joel. Can you say how much NASA is going to pay Boeing for the cargo delivery, the hundreds of pounds up and hundreds of pounds down that you mentioned? And then a question for John. Generally, can you provide any details on the number of software code changes that were made between OFT1 and OFT2? I know you did this analysis and obviously ran all kinds of simulations, but at the end of the day, were there lots of code that needed to be changed, or was it relatively minor? Thank you.
Yeah, I'll take the first question in terms of what we have paid for the cargo delivery to the space station and return. I mean, this flight, Boeing decided on their own to fly a second orbital flight test before they go embark upon the crewed mission, and so NASA did not pay for the cargo delivery at all for this flight.
Okay, and on your question on flight software updates, so coming out of the OFT-1 mission, there were some recommendations out of the independent review team. We incorporated all those recommendations. That was relatively small set. So we incorporated the timer change for the MET Epic. There was a service module disposal software change that we implemented. Actually, the biggest change in software was in the communications code. We found that the communications was not as robust as we would have desired on our first flight. So we spent some effort modifying that code, mostly antenna pointing algorithms, some fault detection and recovery algorithms that we changed. We also added an algorithm so that if we lost comm, that the system would automatically reset and go search for comm. And then we added an algorithm that made sure that post-separation that we had an antenna that was pointed back at Earth so that we could get communication from that antenna. So those were the big ones. There were numerous other changes made to flight software. The majority of those were additions to the flight software for additional functionality that was added to the vehicle, consistent with going from the OFT and bringing us up to the crewed version. And so those changes, and then, of course, learning. We incorporated learning from the first flight into the software.
Okay, Ken, you got a follow-up?
Thanks, Ken Kramer, Space Up Close again. And again, good luck. If I didn't say it the first time, good luck. For Joel, I have a question. This could be for Jennifer, too. When Nauka docks, hopefully it will dock safely, and the Russians, I think, are going to, correct me if I'm wrong, maybe upgrade to 3 crew members. So I'm wondering, would the ISS at some point soon after that reach 8 crew members, and how would that affect the crew and the science on the U.S. segment? I think you have 5 now, but would it go down to 4 if they don't, or how would Nauka impact all that?
Sure. Now, our long-term steady state is 4 USOS crew members, and so 4. And so when the Russians, when they get to the point where they step up with 3 cosmonauts, we'll stay at the 4 USOS. And then what was your second question?
Well, that was it. So
Okay.
they're not going to go to 8 then?
No. We'll stay 4 on the USOS and 3 on the Soyuz.
So you definitely have less U.S. science or partner science then, I guess.
I'll start and then Jennifer can add. The cool thing about the International Space Station is we work, across the partnership, right? So today we have cosmonauts participating in U.S. experiments and vice versa. And so we'll always be working together. Now, each agency has their national goals, and we work those in, but we'll always continue working across borders.
Let's go back to the phone and Joey Roulette with The Verge.
Hey, thanks. My question was asked.
Okay, great. Yeah, go ahead. We'll come over here in a
Hi,
second.
this is for John. Last year, I understand that Boeing hired, I think for the first time, some sort of executive level software person who looked at, software among all aspects of Boeing. Could you tell us a little bit more about that role? When was that person hired? And how did you at Starliner interface with that person? Did they have specific recommendations for the Starliner program? Like, what specifically came out of that?
Sure, I'd be happy to. So actually, even before that, we looked at software, and we have capabilities within the Boeing organization, and so we implemented a software capability as a dedicated engineering discipline to make sure that we were looking at software holistically and that we were implementing it holistically. The other thing we did was we embraced making sure we were looking at hardware-software integration and not just software as a discipline alone. So that's made a big difference on our flight this year. We've put a lot of effort into making sure that we are integrating hardware and software throughout all of the life cycle of the software development. So that's a big change from where we were. As far as, and Jenna was the individual we brought on to the executive ranks. So Jenna has participated. He participates in all of my monthly reviews. He's provided input on recommendations for software updates. Specifically, he's been looking at the CFT software and looking at other ways to test the software and make sure that we've addressed all of the logic paths in it. We went through a great deal of effort to ensure that we had addressed all complex and non-complex logic paths, and Jenna has brought us some new tools to help us do that more efficiently. So we welcome his input, and we are incorporating that into our development process.
I'm going to go to the phone, and then you're next. Camden Hall, talk of Titusville.
Yeah, hi. Thanks for taking my question. My question is for Will Ulrich. If, say, we had a scrub on Friday, could you give us a rough forecast for August 3rd, your next launch opportunity? Thanks.
Yeah, you're talking about a launch Tuesday, so we're, an entire week away. So it's a little early for me to even discuss what the actual forecast would be, but we can look at it from a climatological perspective, and that tells us that given the time of the launch, which I believe, correct me if I'm wrong, it's would be closer to around 1 or 1:30, a little bit earlier in the afternoon, which would be a good thing because at that point the East Coast sea breeze hasn't yet fully matured and we haven't seen as many showers and thunderstorms at 1 p.m. as we will at 3 p.m. So overall, from a purely climatological perspective, I would say that the probabilities are lower. But when it actually comes to the forecast, that first probability of violation forecast that we put out, that won't come until Friday morning. So I really can't talk to it just yet.
Okay, back here, go ahead.
So really, whoever wants to weigh in on this, but this pre-launch news conference kind of signals the beginning of this countdown, right? Everything has been leading to this moment on Friday. You've talked about a lot of the technicalities about the software. I want to know, how are you feeling? How are you weathering the excitement or the nervousness as you look at other companies around you in the past few weeks, or even given the last flight? I want to know how you're feeling today.
I guess I can start. I mean, been in this business a long time. I was just thinking back to a July launch on Space Shuttle. July 4th, in the middle of the afternoon, we launched 121, the second return to flight mission, and it was that was an exciting flight. But we talk about weather in the afternoon, and sometimes you can launch in the afternoon. But And I would say for any flight, I'm excited, I'm anxious and looking forward to it. But, I think if you're not a little worried or concerned or have a little bit of that tension in your stomach, like what we're about to do is really challenging. We want it to go well. We expect it to go well. We've done all the preparations we can possibly do, and the Boeing team and the NASA team continues to do that, even running simulations up until the last minute. But, there's always a little bit of that trepidation in you that, hey, this is space flight. The Atlas is a great vehicle. Starliner is a great vehicle, but we know how hard it is, and it's a test flight as well. And I fully expect we'll learn something on this test flight. We have a lot of instrumentation on the vehicle, strain gauges and pressure temperature measurements and accelerometers and all kinds of things. And so when we get back, we'll take that data and then fold it into the crewed flight test as well.
Anybody else in the room?
Yeah, I'll add in that,
Sorry, John.
Of course, we've been 18 months preparing for this, right? And so I am confident in our vehicle. That said, we do have to, ensure that we are carefully watching all the systems. We want to learn from this flight. We want to let the hardware talk to us so that we understand, what it's telling us, right? Because there's a lesson to be learned there. On the first orbital flight test, we learned a lot. We learned that we had a very robust vehicle, in fact. It performed better in a lot of respects than we, had expected. So we tested that vehicle. We learned those things. We learned that our communication system was robust, so that we made the changes there. We made the changes in our software. We have spent the 18 months really trying to wring this vehicle out to have a lot of confidence that this flight will be successful. We will learn something out of this flight. There's no doubt. But we want it to be a successful flight, and that the learning is something that we incorporate back to make this a safer, more robust vehicle.
Okay, let's see. I'm going to jump in with a question, reformulated a little bit for online. But how long will Starliner stay at the ISS, and what will be the main mission objectives? I think the question is alluding to what did we get done on the first test flight that we may redo on this flight, and also accomplish all the other mission objectives that we had. And that may be for you, Steve, and also for John.
Yeah, I could take a crack at it, Kyle, and then we'll let John add to it. The first flight, as John said, I think we learned that we fundamentally had a very solid design in the spacecraft in terms of the crew module and the service module. That mission, in some ways, performed better than we would ever anticipated with the number of thruster firings we had, the way that the battery and power system performed, the way the GNC system performed, the prop system performed well, the landing and guidance. We landed almost a bullseye at White Sands, so that part of the flight went extremely well. The part that we'll really focus on here is going into the approach ellipsoid and testing the rendezvous Vesta sensor system. That's necessary to get in close to ISS and track the docking interface, docking with the International Space Station, testing out the NASA docking system. That system's provided by NASA. Starliner's computers control that system, getting into docking, and then once we dock, opening the hatches, and then power transfers back and forth between the vehicles. So while the vehicle's at ISS, we'll flow power over and provide power to the Starliner batteries. We'll exchange data and caution and warning between the vehicles while we're docked. We exchange atmosphere back and forth. We'll look at the temperatures in the cabin and learn a lot about the flow rates. And then there's an emergency communication system between the vehicles. So if a crew were in Starliner in some kind of a safe haven or emergency, they could talk to the crew on the ISS side. So it's really all those kind of things that we'll learn. The plan is for the flight to be relatively short and undock as early as August the 5th. Should we launch on the 30th? We'll stay up a little longer if weather allows for it. And then, it really is just to learn about the docked part of the flight. That's the part of this flight that to me is so critical, docking with station, and then also on the back end as well, going through that whole undock sequence, testing the NASA docking system as well, and having Starliner back away, and then from there separating away and getting into the deorbit burn and landing. And I'll see if John has anything to add.
Yeah, Steve captured all of the major demonstrations of capability that we're looking to do. I think I would add to that there are systems that we test as best we can on the ground, but there are conditions that are only found on orbit that we're going to be able to fully test out some of our systems. So our Vesta system, which is our vision system for docking, we'll be very interested in gathering data from that system so that we can understand the characteristics of that system and how it operates in an on-orbit environment. So those are additional things we'll be looking for is, once again, what's the hardware telling us and what do we learn from that?
Okay, thanks. We'll wrap up with just a few programming notes. Thursday is obviously going to be a busy day at the space station getting ready for Starliner's arrival and also here on the ground. So be sure to join the NASA administrator here on NASA TV and in this room at 10:30 Thursday morning for an entertaining media and social event. He'll be also joined by some of the other agency leadership and some other special guests, so hopefully you guys can join us for that. Obviously, all of that leads to Friday. 2 o'clock is our start time for the broadcast. It's a comprehensive set of launch coverage that includes taking you inside some of the facilities here, Boeing's Mission Control Center, the United Launch Alliance's Atlas Space Flight Operations Center, and obviously Mission Control Houston. Liftoff remains scheduled for 2:53 p.m. Thanks for joining us today, and be sure to follow us online at our main sites, nasa.gov/live for the live broadcast and live events, and also for the commercial crew program, nasa.gov/commercial crew. Thanks to the panel, and also thanks to you guys for being here, and please keep practicing social distancing. Thank you very much.